Imagine a world where every secret you've ever entrusted to the digital realm, your bank account, your private messages, even the security codes protecting nations, could be unlocked in seconds. A world where the balance of global power shifts overnight, not through wars or treaties, but through a single technological breakthrough. This isn't science fiction, it's the promise and peril of quantum computing, a field where Microsoft, a name synonymous with software, might be quietly rewriting the rules of the future. Today, we're diving into the enigma of Microsoft's quantum ambitions, a story of hidden labs, cryptic patents, and a race that could redefine everything from national security to your daily life. Buckle up, because this journey into the quantum frontier is as thrilling as it is unsettling, and by the end, you'll be itching to share your thoughts on what this all means, because the stakes couldn't be higher. Quantum computing isn't just about faster computers, it's about rewriting the laws of what's possible. Unlike classical computers, which process information using bits, zeros, or ones, quantum computers use qubits that can exist in multiple states simultaneously thanks to the mind-bending principles of quantum mechanics. This allows them to tackle problems, like cracking encryption or simulating complex molecules, that would take classical supercomputers billions of years. As of September 22nd, 2025, the race to build a practical quantum computer is heating up, with implications that ripple far beyond Silicon Valley. Why does this matter? Because the first to master quantum computing could hold the keys to the digital world. Encryption, the backbone of modern security, relies on mathematical problems that classical computers can't solve quickly. Quantum computers, however, could crack these codes with ease, exposing everything from financial transactions to military secrets. At the same time, they could create unbreakable encryption, giving their creators unprecedented control. Governments, intelligence agencies like the FBI and CIA, and corporations are watching closely, not just for scientific glory, but for global dominance. And at the center of this high-stakes race is Microsoft, a company whose public quantum efforts may only be the tip of the iceberg. Let's set the stage. Microsoft has made headlines with its quantum research at public facilities like Station Q in California, the Qubit Group in Redmond, Washington, and a lab in Lyngby, Denmark. In 2024, they unveiled the Majorana 1 processor, a quantum chip that promises stability and scalability far beyond competitors. But whispers of secret labs, cryptic patents, and government funding suggest there's more to this story. What if Microsoft's public breakthroughs are just a distraction from something far bigger? Let's explore the clues, piece by piece, and uncover what might be happening behind closed doors. Microsoft's quantum journey is anchored in three well-known research hubs. Station Q, based at the University of California, Santa Barbara, is led by renowned physicist Professor Michael Friedman. It's a place where computer science meets the strange, almost magical world of quantum physics. The Qubit Group in Redmond, Washington, focuses on quantum algorithms and software, crafting the code that will run on future quantum machines. Meanwhile, the Lyngby facility in Denmark is a hub for hardware innovation, where engineers tinker with exotic materials to build the next generation of quantum processors. In 2024, these labs made waves with the Majorana 1 chip, a breakthrough that stunned the tech world. Unlike traditional qubits, which are notoriously fragile, think of a spinning coin that stops if you so much as look at it. Microsoft's chip uses topological qubits based on Majorana fermions, elusive particles that exist at the ends of specialized nanowires made from indium arsenide and aluminum. These qubits are like knots in a quantum fabric, incredibly stable and resistant to errors. While other quantum computers need thousands of physical qubits to create one reliable logical qubit, Microsoft claims their approach drastically reduces this overhead. Tests of the Majorana 1 show error rates far lower than competitors, a leap that could bring practical quantum computing within reach, not in decades, but in years. This public story is impressive, but it's also carefully curated. Microsoft's press releases paint a picture of steady progress, but the timeline doesn't quite add up. In 2018, they announced a Majorana breakthrough, only to retract it in 2021 after experimental errors were uncovered. For 3 years, they went silent. Then in 2024, they re-emerged with a working processor based on the same technology they'd supposedly failed to prove. How did they bridge that gap so quickly? The answer might lie in what Microsoft isn't telling us. To understand the full scope of Microsoft's quantum ambitions, we need to follow the breadcrumbs, starting with their patents. As of September 22, 2025, Microsoft has filed dozens of quantum computing patents that reveal capabilities far beyond their public announcements. These aren't just about faster processors, they describe technologies straight out of a sci-fi novel, braiding Majorana modes, quantum teleportation channels, and topological quantum error correction. One patent outlines methods for fault-tolerant quantum cloud integration, suggesting Microsoft is already thinking about scaling quantum computing to the masses. Another details quantum networking protocols that could form the backbone of an unhackable internet. Most intriguing are patents combining quantum computing with artificial intelligence, hinting at neural networks that process information in ways classical computers can't. These patents are like footprints in the sand, evidence of progress Microsoft isn't openly discussing. They suggest research years ahead of what's shared in press releases. But where is this work happening? Microsoft's public labs are impressive, but satellite imagery and facility details raise questions. The Redmond campus, for instance, includes windowless buildings with heavy shielding, designed for something more sensitive than office work. The Lyngby facility boasts massive rooftop infrastructure consistent with cryogenic cooling systems, essential for quantum computers that operate at temperatures colder than deep space, just a fraction of a degree above absolute zero. Why would these facilities need such extreme infrastructure if they're only conducting the research Microsoft publicly acknowledges? Then there's the timeline gap. The leap from a retracted claim in 2021 to a working Majorana 1 chip in 2024 suggests intensive work during those silent years. Some speculate an undisclosed facility, a secret lab, bridged that gap hidden from public scrutiny. The involvement of DARPA, the US Department of Defense's research arm, adds fuel to the fire. In February 2025, DARPA named Microsoft one of 2 companies in the final stage of its US 2QC program, pouring millions into building utility-scale quantum computers. If DARPA is publicly backing Microsoft, what classified projects might be underway behind closed doors? What do you think? Could Microsoft be hiding a quantum lab that's already testing technologies we won't see for years? Drop your theories below, because this puzzle is far from solved. Microsoft's quantum work isn't just a scientific endeavor, it's a geopolitical lightning rod. Quantum computing is at the heart of a new global arms race, one that could reshape power dynamics for decades. The moment a quantum computer can break RSA encryption, the foundation of modern cybersecurity, experts call it Quantum Day Zero. On that day, everything from bank accounts to nuclear command structures becomes vulnerable. Microsoft itself has warned of a harvest now, decrypt later scenario where adversaries are already storing encrypted data, waiting for quantum computers to unlock it. Years of secrets, personal, corporate, and governmental, could be exposed in an instant. The stakes are staggering. Financial systems could collapse if transactions are no longer secure. Military communications, from drones to satellites, could be compromised. Entire nations could lose control of critical infrastructure. This explains why DARPA is so deeply invested in Microsoft's research. Their topological qubits, with their promise of stability and scalability, could give the US a strategic edge. But Microsoft isn't just racing against Google or IBM, they're up against entire nations. China has poured billions into quantum research, with state-backed labs pushing for supremacy. Europe's quantum flagship initiative is mobilizing resources across the continent. The first to achieve quantum supremacy won't just win scientific acclaim, they'll gain the ability to see what others can't, control what others don't, and potentially dominate the global stage. Microsoft's public quantum safe initiative, launched to develop encryption that can withstand quantum attacks, shows they're preparing for this future. But who will control these new standards, and who gets access first? If Microsoft masters unbreakable cryptography, they could hold the digital backbone of society in their hands. This isn't just about technology, it's about power, control, and survival in a post-quantum world. The implications of Microsoft's quantum research extend far beyond breaking codes. They're exploring applications that sound like they belong in a blockbuster movie, yet they're grounded in physics we already understand. Let's explore 3 frontiers that could redefine our world. First, quantum AI. Today's AI models, like those powering chatbots or image recognition, rely on massive datasets and energy-hungry processors. Quantum-enhanced neural networks, hinted at in Microsoft's patents, could learn in fundamentally different ways. Not just faster, but smarter. Imagine AI that doesn't just mimic human intelligence, but surpasses it, solving problems like climate modeling or drug discovery in hours instead of years. If Microsoft is already testing quantum AI, it could render current models obsolete, like comparing a horse-drawn carriage to a jet plane. Second, quantum sensing. These devices could detect minute changes in gravity, electromagnetic fields, or even time itself. Picture navigation systems that don't rely on GPS, or sensors that can see through walls or detect submarines deep underwater. Quantum radar could track stealth aircraft invisible to conventional systems. Such capabilities would revolutionize military and civilian applications, making secrecy around these developments understandable. Finally, quantum communication. Using entangled particles, Microsoft could be developing networks where information is transmitted instantly across vast distances, completely immune to hacking. Any attempt to intercept the message would destroy it, ensuring perfect security. This could create communication networks beyond government control, reshaping everything from diplomacy to personal privacy. These possibilities explain why Microsoft might keep some research under wraps. The company that masters quantum sensing could render traditional defenses obsolete. Quantum communication could redefine global networks. And quantum AI, it could change what it means to be intelligent. Microsoft's focus on topological qubits, with their stability and potential for real-world use, suggests they're not just building computers, they're building the future. Let's bring this home. What does quantum supremacy mean for your daily life? Imagine waking up to find your bank account drained because quantum computers cracked the encryption protecting your funds. Your medical records, once private, are now an open book. Every email you've ever sent, every password you've used is suddenly transparent. This isn't just about future risks. Because of harvest now, decrypt later, adversaries could already be storing your data, waiting for the day they can unlock it. The global impact is even more daunting. Financial markets could collapse if transactions aren't secure. Military systems, from nuclear arsenals to satellite defenses, could be compromised, shifting the balance of power overnight. Entire economies could grind to a halt. Microsoft's quantum safe initiative is a step toward mitigating these risks, but the question remains, who controls the new encryption standards? If one company holds the keys to an unhackable digital world, do they effectively own it? This isn't just a corporate race, it's a human one. The technology Microsoft is developing could determine who controls the future, from governments to individuals. And with their Majorana 1 chip showing a path to practical quantum computing in years, not decades, that future is closer than you think. The deeper we dive into Microsoft's quantum endeavors, the more we confront an unsettling question. Should any single entity, corporate or governmental, wield the power of quantum supremacy? The potential of quantum computing to reshape society is matched only by the ethical dilemmas it raises. If Microsoft or any company develops the ability to crack every digital lock in existence, they could theoretically access the world's secrets, bank accounts, government communications, personal data, without anyone knowing. But it's not just about breaking codes. The flip side is the creation of unbreakable encryption, a tool that could secure the digital world, or, in the wrong hands, enable untouchable criminal networks or authoritarian regimes. The balance of power hangs on a knife's edge, and the decisions made in hidden labs today could dictate the freedoms we enjoy or lose tomorrow. Microsoft's quantum safe initiative is a proactive step, but it also raises concerns about who sets the standards. If they control the new cryptography, do they become the gatekeepers of the digital age? The implications stretch beyond technology into philosophy. What does it mean for a corporation to hold such power, and how do we ensure it's used responsibly? These are questions we can't ignore, and they demand a global conversation, one you're invited to join by sharing your perspective in the comments below. Let's zoom in on the science driving this revolution, because the technology itself is as fascinating as its implications. Microsoft's Majorana 1 chip isn't just a step forward, it's a leap into uncharted territory. Topological qubits, the heart of their approach, rely on Majorana fermions, particles that are their own antiparticles, existing in a delicate dance at the edges of nanowires. This isn't just physics jargon, it's a game changer. Traditional qubits are prone to decoherence, where environmental noise, like a stray photon or vibration disrupts their quantum state, rendering computations useless. Microsoft's topological qubits, however, are braided in a quantum fabric that resists such interference, like a rope that holds strong under strain. This stability could reduce the number of physical qubits needed for a single logical qubit from thousands to mere dozens, making scalable quantum computers feasible sooner than expected. As of September 22, 2025, Microsoft claims their chip is a stepping stone to systems with millions of qubits, compared to the few hundred in today's most advanced systems. This isn't just an incremental improvement, it's like jumping from a bicycle to a rocket ship, but the real question is how far they've already gone. The patents hint at quantum cloud integration, suggesting they're not just building machines, but envisioning a world where quantum power is as accessible as your smartphone. What does this mean for industries like pharmaceuticals, where quantum computers could simulate molecules in seconds, or logistics, where they could optimize global supply chains in real time? The possibilities are endless, but so are the risks of such power being concentrated in one company's hands. The quantum race isn't just Microsoft's story, it's a global saga with players vying for supremacy. China's quantum program, backed by billions in state funding, has made strides with systems like Zhejiang, which demonstrated quantum advantage in specific tasks. Europe's quantum flagship, a €1 billion initiative, unites researchers across the continent to keep pace. Even smaller players like Canada and Japan are investing heavily, recognizing that quantum technology could redefine economic and military power. Microsoft's edge lies in its topological approach, but competitors like IBM and Google are pursuing their own paths, with superconducting qubits and other architectures. The race is neck and neck, and the winner could set the global agenda for decades. Yet the involvement of DARPA in Microsoft's work adds a layer of intrigue. If the US government is funding unclassified projects, what might they be supporting in secret? Classified contracts could mean Microsoft is developing applications, quantum radar, cryptographic backdoors, or AI agents that we won't hear about until they're deployed. Meanwhile, nations like China are reportedly stockpiling encrypted data, betting on future quantum breakthroughs to unlock it. This harvest now, decrypt later strategy means the race isn't just about who builds the first quantum computer, but who can exploit it first. The global implications are profound. A single breakthrough could shift alliances, disrupt economies, or even spark conflicts. As we stand on the brink of this new era, the question isn't just what Microsoft is building, but whether the world is ready for what comes next. Share your thoughts on who you think will win this race and what it means for the future below. As we piece together the clues, patents, shielded facilities, DARPA funding, and timeline gaps, one thing is clear: Microsoft's quantum ambitions go far beyond what they share publicly. The Majorana 1 chip is a milestone, but it's also a signal that the real breakthroughs might be happening in the shadows. Are there secret labs pushing the boundaries of quantum AI, sensing, or communication? What capabilities have they already achieved that we won't know about for years? And most importantly, are we ready for the world their technology will create? This story isn't just about Microsoft, it's about a paradigm shift that will redefine our digital lives. From unbreakable codes to unhackable networks, quantum computing could usher in an era of unprecedented security or vulnerability. The race is on, and the finish line is closer than most realize. What do you think Microsoft is working on behind closed doors? Could they already have technology that changes everything? Share your thoughts in the comments below, and let's spark a conversation about the future. If this story gripped you as much as it did us, hit that like button to show your support, and subscribe to stay ahead of the curve on groundbreaking discoveries. The quantum revolution is coming. Don't miss what's next.